We're doing number 37 on the practice final about a flu virus spreading. The first step is to set up a chart. You have whether or not someone has the flu, whether or not they've been vaccinated, and now I have to try and draw straight lines, which is tricky. Okay, so I'm going to use our numbers that we have and plug them in the right spots. So the total number of students in the classroom is 53. 26 students have been vaccinated. Where does that go?
Say that one more time, I'm sorry.
The 26 students that have been vaccinated, where does that go?
Under the total under vaccinated.
Yep. There have been 15 cases of the flu. Where does that number go?
Total for has flu.
Total for has flu. 4 students who have received the vaccine did catch the flu. So that's there, the vaccinated and has flu. So now in green, I'm going to do the rest of the numbers. So 53 minus the 15 gives me 38. 26 minus 4 gives me 22. 15 minus 4 gives me 11. 38 minus 22 gives me 16. And 53 minus 26 gives me 27. Everyone okay with the 2 steps of filling in the table? So what's the chance that someone catches the flu if they're not vaccinated? There's 11 people that had that happen.
11 out of 27.
11 out of 27. So about 41%. What's the chance to catch the flu if you are vaccinated? 4 people had that happen out of the 26 that were vaccinated. And then I'm going to stop talking and you can try on your own to do what is the absolute change, the difference, subtract between these 2 numbers, and what's the relative change, the percent change between those 2 numbers. We're back to recording. So hopefully you've thought about this a little. And we have 2 numbers, 41 and 15. And I'm going to just pick a new page and look at these 2 numbers with a new context, because the old context is part of what's making it confusing. So if I just said I have 41 cutie tangerines in a bowl and Marjorie has 15, how many more do I have? There's 2 ways to answer the question. We could say, well, 41 minus 15. And subtraction is a way that we've been dealing with how many more since elementary school, right? I have 26 more. That's great math. It works great. Nothing wrong with that. We understand that. We could also be fancy and say that there's a percent change. A percent change is change divided by original. We've dealt with this a lot also. We haven't dealt with it for as many years as we have subtraction, but we've seen this an awful lot. So I would take the 41 minus 15 as the 26, that change we got before, and divide it by the original. And say that I have 63%. I am sorry, let me back up. I'm comparing things to Marjorie's, so she should count as our basis of comparison, as our original. So I would say I have 173% as much. I have 73% more than she does. Why did I, yeah. So this was our original, our basis for comparison. On the bottom. And so on. So that's two ways of thinking. I could also do 41 divided by 15, but that's going to be even more confusing. So we're going to do the same thing with these two numbers. Somebody could say, and they're not lying at all, that as an absolute change, no, I think I like the 41. Yeah, you lost 73. Anyway, I explained this page badly. Should I start over?
Yeah, because I was looking at Monday's Jamboard and now I'm complete. That made sense to me and now I'm confused.
Okay, let me go back then. I am sorry. So I'm too tempted talking about Marjorie's first to do 41 divided by 15. So I want to talk about mine as the original. So how much less does she have than me? So she has 56% less than me. Uh, 56% is missing, I guess would be one way to say it.
Where did the 56% come from?
Because I'm taking the change, the 41 minus 15, and dividing it by what was the original, what was mine from my point of view. So more than half of mine are missing by the time we give them to Marjorie.
So when I do 26 divided by 41, I got
I'm hitting the wrong thing in my calculator. It should be
0.634, so rounded to 63%.
Yes, you are right. I for some reason hit the wrong thing. This is really terrible. Anyway, okay, now that we're finally there. So I had 41 pieces of fruit. I wanted to give some to Marjorie. I ate a bunch on the way over to her house. 63% of them go away before I finally give her the 15. Or we could say I ate 26 of them on the way to her house. Okay, so we'll do the same two things. The absolute change is the 41% minus the 15% equals 26%. So the chance to get the flu goes down by 26%, just like 26 of the pieces of fruit got eaten as I was walking to Marjorie's house. And we can also do a relative change. So a percent change over original. Now I'm glad I did set it up the way I did because this will actually match. So how can we have two answers? The chance is 26% less or 63% less for the same thing. The first one both of these percentages were based on the total people in their group. So this 26% is what percent chance less is there of just a random person getting the flu. We don't know if you were destined to get the flu or not, but if you are just somebody walking around, this is sort of what's the reduction of your chance to get randomly hit by flu. The 63% is when we're focusing on the people who would catch it. It's sort of in your destiny to catch the flu. And then the chance when you're vaccinated is smaller, only 4 out of 26 instead of 11 out of 27. So most of those people are able to avoid the flu because of the vaccine. This number is bigger because the vaccine helps more if you're someone that was going to get the flu for sure. If you're someone that just might never catch it anyway, you're never destined to have contact with the people that would make you sick, then of course the vaccine isn't going to help you as much because there's a good chance you just wouldn't get it anyway. So they are both legitimate answers, but just to two different questions, because we can subtract to think about more, or we can do percent change to think about more. Hopefully that was okay, even though I bungled slide 11 so badly multiple times. Another quick concluding thing for the term is about standard deviation. In the textbook, it gets into a detail we didn't. It talks about how the standard deviation might be from a whole population, you know, every number in the data set, or maybe you're taking a sample. If you're just studying the people that you meet on the street and surveying them, if you're talking about the homeless population in Eugene and surveying them, something, then you don't have every piece of data, you're just sampling. And for a very specific reason, when you're finding standard deviation, the formula is slightly different. We're not going to get into why, but if you're using the whole population, copying that box there, then the button on your calculator is the one that says standard deviation P, because you know the whole population. And so when the problem says, what's the standard deviation of these four numbers, you could work it out the long way. The practice finals tell you how to sum up the numbers, find their mean, find each of the four deviations, take the squares, take the mean of those, and then divide by the square root. But you don't actually have to do that. You can just use your standard deviation P button, put in the four numbers, and get an answer, and ta-da, be done that way. But don't use the standard deviation button that lacks the P. That would be if we're sampling. Maybe we have these three, maybe we have those three, maybe we have these, who knows? It's a little bit of randomness to it. And so the formula is a little different and will give you a different answer. And if you take a real statistics class, you'll find out why that's important. Now we're on 35. Maybe we'll fit 36 on the same slide, or maybe not. So a student is about to take the final. His grades so far in the class are listed below, and the weights of each part of the class towards the overall grade. What percent score is needed on the final so that overall it's a 74%. So Ashley had offered to walk me through, what do I do first?
Okay, so from my notes, what I have is ignore the percentage on the scores.
Okay.
And then we want to find the expected value, which means we're gonna take 88 times 0.18, and it's gonna give us the expected value of 15.84. And then we're gonna go down to homework, which is 89 times 0.20, which is 17.8. Midterm number one is 68 times 0.14, which gives us the expected value of 9.52. And then midterm two, 56 times 0.16 gives us 8.96. And then we're gonna add all of those, which I haven't gotten that far yet. So give me 1 second to give you the answer. Which is a total of 52.12. And then we want 74%. So it's gonna be 74 minus the 52.12. And that is 21.88. So we are doing y times 0.32, which equals 21.88. And then we're going to divide 0.32 from both sides to get y alone. And then once we do that, we have two. Oh wait, did I just do that wrong? Oops, I just lost myself. So we have 21.88 divided by 0.32, which gives us about 68%, I think.
Remember at the beginning, Ashley removed the percent signs so we wouldn't confuse ourselves with riplops. So we can just put a percent on here. This is a label of those scores. It's not that we had to do riplop to get this to be a percent. These could have been counting apples or oranges or elephants or umbrellas or something else. They happen to be counting percents. So our answer has the same. Okay, and since that was a lot of work for 1 point on the test, then you get an easy problem to get another point. What is 68% of? So 0.68 times 27. It's 18.36. So we're always going to want to round up here. Otherwise, we're going to not quite have enough points. So this person in the problem needs 19 questions correct to get the grade they want for some reason. Tangentially, what do we need? So according to our chart, oops, there we go. Then here's how you are graded in our class. And the top of the test says that your best 35 problems count. You can do the extra 2 because there's 37 on the test, but those are just kind of your backups, your extra credits, your top 35 credit, 35. So if you are going for an A, you need 85%. So 0.85 times 35, which is 29.75. We'll round up to 30 problems. I'll grade with a little bit of partial credit because everyone makes silly mistakes here and there. So maybe you will get 28 problems all the way correct and 4 problems halfway correct or something like that. But in overall 30 problems is your goal. If you're aiming for a B, then you're at 0.75. So you need about 26 correct. And again, that might actually look like 24 correct and then 4 others halfway correct or something like that. So if on your practice tests, you're getting 26 or 30 correct, then you're on track to get an A or a B.